All right, if you've ever dipped your toes into coding, you've probably hit a wall thinking, how do I handle a ton of information at once? Well, today we're pulling back the curtain on one of the most essential tools for that exact problem, the array.
So first up, let's talk about why we even need something like an array in the first place. It all comes down to a super common issue, what I like to call the data overload problem.
Okay, so let's put ourselves in a real-world situation. A teacher asks you to build a simple app to track test scores. Easy enough, right? But then they tell you they have 100 students, 100 different scores. How in the world are you going to store all of that?
Well, you know about variables, right? Your first thought might be to create a variable called test score. But here's the problem. A variable is like this tiny box that can only hold one thing. The moment you put a new score in, the old one gets booted out. So that's definitely not going to work for 100 scores.
So what's plan B? Maybe test score 1, test score 2, test score 3, all the way to test score 100? I mean, you could do that, but can you just imagine the headache of trying to manage all of those? It's clunky, it's messy, and frankly, it's just bad coding. There's got to be a better way.
And of course, there is. This is where our hero of the day comes in. Let's introduce the clean, elegant solution to our data overload problem, the array. This is the tool that's going to let us organize all that info neatly.
So, what in the world is an array? Think of it like a filing cabinet. It's got one single name on the outside, maybe math test scores, but inside you've got a whole bunch of perfectly organized drawers, and each drawer holds one piece of information. The key things here are that it's an ordered collection, and everything inside is the same type of thing. So let's get down to the nitty-gritty. The key characteristics that make an array, well, an array. First, you get to store tons of values under just one name, so that whole test score 1, test score 2 nightmare is gone. Second, everything inside has to be the same data type. So you can have all numbers or all text, but you can't mix and match. And this one's a biggie. Its size is fixed. If you build it to hold 100 scores, it's always going to have exactly 100 slots. These rules are what make it so incredibly efficient.
Okay, we know what it is. Now let's pop the hood and take a look at the different parts. Let's really see how this thing works from the inside out.
Okay, this diagram right here is perfect. It gives us a great visual of what we're talking about. We've got this single container holding a bunch of different numbers, each in its own little compartment. We're going to break down every single piece you see here.
First up, the element. This one's easy. The elements are just the stuff, the actual data you want to store. In our example, it's the test scores themselves, 71, 80, 85, and so on. So how do you find any of that stuff once it's in there? That's what the index is for. You can think of it as the address or the slot number for each element. It's how we tell the computer, hey, I want that specific one. Now listen up, because this is the number one thing that trips up everybody when they start. So really let this sink in. In the world of programming, we don't start counting at 1. The index always begins with 0. That means the very first item in your array is at index 0. The second is at index 1, and so on. It feels a little weird at first, I know, but you'll get the hang of it fast.
And this little comparison here is a game changer for understanding that whole starts at 0 thing. Let's say you have an array with 7 elements. The size is, well, 7. Simple enough. But because we started counting the index from 0, the very last address, the last index, is going to be 6. The last index is always just the size minus 1. And this table just wraps it all up in a neat little bow. You've got the array's name, which is marks. You've got its size, or length, which is 7. You have the elements, the actual scores inside. And you have the index, the address for each of those scores, starting from 0. It all works together beautifully.
Awesome. Theory's down, we get the parts. Now for the fun part. What does this actually look like when you're typing away at your keyboard? Let's get practical.
And there it is. In a lot of programming languages, it's literally this simple. You declare the type of data, in this case int for integers. You give it a name, marks, with some square brackets to say, hey, this is an array. And then you just list out your values. Look how clean that is. One line of code just replaced 7 separate variables.
Okay, so the data's in there. It's stored. But now how do we get it back out? How would we go about grabbing that very first test score, the 71?
It's super simple. You use the array's name, marks, and then in those square brackets, you just pop in the index of the one you want. And remember that golden rule? The first element is always at index 0. So marks 0 points right to that first slot and gives us the value 71. If we wanted the third score, 85, we'd use marks 2. See how that works?
All right, let's bring it all home. If you walk away with anything today, let it be these 3 key takeaways. Number 1, arrays are for storing a bunch of values of the same type under one single name. Number 2, once you create them, they are fixed in size. And number 3, the one you'll use every single day, the index, that position number, always starts at 0.
So there you have it. You now have this incredibly powerful, fundamental tool in your coding toolkit. And trust me, arrays are everywhere. They are the building blocks for so many other complex things you'll learn later. This opens up a whole new world of possibilities for you. So the real question is, now that you know how to organize data like this, what are you going to build?